We're gonna start pretty soon. Um, if everyone could type their what their grade in the chat, that would be nice to see. Um, so thank you for coming. This workshop is for becoming a better programmer, dealing with clean codes, and the principles for clean code, by myself, Kobe Braga, and Yuval Mar.
Hello.
Um, yeah. So a lot of freshmen, second year, one for like 2 second years, third year. Okay, nice. So yeah. This next slide, and then
Sure. So just before we start, we just want to quickly mention that a lot of the tips that we're going to give you guys today are mainly guidelines. These aren't like rules necessarily, but they could be rules depending on where you end up working. So usually wherever you're going to end up having a job, there's going to be some kind of coding standard that you would have to adhere to. And sometimes this coding standard might be against some general guidelines, and that's completely fine. So the most important thing, and uh, the thing that we would want you to get out of this workshop, is to try and be like as clean and readable as possible, but most importantly, be consistent with whatever the standard is and whatever environment you're working in. So just as a quick example, we'll get more to this later, but in Unreal, where the naming convention is in Pascal, not camel case, which means that every variable starts with a capital letter, which typically you don't do in C++. But and if you did that in while working on an Unreal project, that would be going against the standard. So you wouldn't want to do that. So most important thing before we start is these are guidelines. And even if there's a style that you think is less readable in whatever environment you're working in, you should still just be consistent, because that's the most important thing, is consistency. Cool. Yeah, thanks, Kobe. Kobe has a example in the chat if you guys don't know what Pascal or Camocles is, but we'll get to that in a little bit. Kobe, want to take this one?
yeah, it was alternate. So why are you guys here? Well, for first thing, it's for you. So in this case, for an example, right, you're working on a big project during summer, and then you decide to take a break during fall because you have classes, and then you want to come back to that project in winter break, right? Well, if you have bad code, you all of a sudden you're spending like a week trying to figure out what you did earlier, which could be time for new things you could add. So having clean code makes it easy to have readability. Next thing is easier to get new programmers on board. So for say you want to add your friend to the project, and then your friend's like, oh wow, look, I can read all of this with ease. I know what's going on here. Then it's gonna be easier for you guys to start working together. Otherwise you both have like split times, and yeah, it's awful if you have bad code for someone else. Next point is much easier debugging. Get on as we'll talk more later on, clean code usually results in like searchable code, and with that you can much easier find like points that don't work in your code instead of guessing which points don't work. So this goes to the next thing, it's more efficient maintenance. In this scenario, maintenance means updating. So whenever you add new features to your code, it might also affect like other code, and it makes it easier to change the other code, because you know where that code is and what it exactly does. So this is more in the work field or in like a school project where, so an example here is we have two teams on a company. Team one, if you show the next two bullet points. So team one is usually like the old team where they're already used to the code and they're trying to fix it, while team two is the new team and they're trying to understand the old code before merging to team one. So with clean code, you can make this process faster and then create more efficiency for your company. last but not least, it takes practice. Writing clean code is a long-term marathon, not a sprint. So starting early will make it easier for you to be used to writing clean code, which everyone will like. So yeah, here's a quick picture if, society, if every coder attended this workshop, but it is what it is.
Yeah, unfortunate. Unfortunate. Just quickly, this is the table of contents, just in case you're wondering what we're going to be covering. I think there's a good enough mix of people here. They should be able to get like at least something out of the beginner, intermediate, and advanced topics, but this is what we're going to be talking about.
Okay, I'll take 1, 2, and 4, and then you can take over 3, Yuval. So some general
Okay, sure.
rules. So first one, follow standard conventions. Again, it's a general like guidelines per se, not really like hard rules, but so don't stray from like normal things, even though if it may seem easier or better to do for you. So if a company like does a specific way with like their names, and you're like, that doesn't make sense. I think this would be easier. Well, you wouldn't do it by yourself. You would probably like take it up with your management or something. But yeah, just follow conventions that are around you in your environment. Number 2, keep things simpler to simple. That means reduce complexity as much as possible. There's a lot of people that might read your code and they'll have different backgrounds. So, the more simpler it is, the less like uniqueness you're isolating from your population that reads your code, for lack of a better way to say it.
Right, and then for Boy Scout rule, that's basically, for those who haven't heard of it, it's basically like leave things better than you found them. So as an example, during my internship this last summer, part of the work I did was, in addition to working on features, I also cleaned up some code, which in turn helped me, but also helped anyone that would look at that code later on. And a big reason to do that is because if everyone was able to clean up a little bit when they're working in a particular file or whatnot, then eventually, the code would be much easier to work on. So part of the reason in my example, when I cleaned up code, is because I actually had a really hard time understanding it at first. So don't be surprised, no matter what company you end up working for, there's always going to be some code that could have been written in a better way. And it's very important to not have this like not my job attitude, and try to be more proactive and plan ahead for the future.
Yes, we need more people like Yuval. So for number 4, always find root cause or cause. This is more for debugging and fixing your code. As the image on the right shows, make sure you always try to like find a root cause, meaning that you don't just fix service level problems, because if you do, then that just leaves work for someone else, and that's really bad and just decreases efficiency. So don't be lazy. Always try to find like the root of your problems. It's a general rule. So yeah.
Yeah, and also I just want to add, if anyone has questions at any time, please just write in the chat. Like, don't be shy. Cool. So Kobe, you want me to take this one? Sure. So just some general principles. First of all, dry, don't repeat yourself. So an easy example of this is if you have some kind of logic that is used repeatedly in your code, then maybe you should use a function in order to implement that logic instead, and then call that function multiple times, right? You don't have to like, if you're copying and pasting code, then that means you're probably doing something wrong. Second is kids would just keep it simple, stupid.
Yeah.
No, you're not trying to impress anyone with your code, right? Like, I know there's some people who really like using like all the most, like for example, C++, like using all the most advanced and new C++ features. And that's great as long as it's readable and understandable. But if no one around you knows or understands these features, then there's no point to just use every single feature you can for no reason. So just keep it as simple as possible so it's understandable, not just for other people, but also for your future self, right? There's a chance, excuse me, there's a chance you'll have to go back and look at that code again in the future. And three, Kobe, how do you pronounce that?
Just I think Yagni. I don't really
Yagni.
know.
Do you wanna go
Yeah,
over
I'll
that
take the
one?
last two. So yeah, so Yagni is just you aren't gonna need it. Meaning don't add things that aren't necessary for the code. A lot of people overthink and add things that like, oh, we probably need this, but in reality you don't. A common example I find myself doing is using, so ever since I learned what maps are, I've been using them for everything, even though they might not add anything to the code. Like a vector might be way better. Number four is favor readability, which so what really counts for your code is that the people reading it, not the machine. So make sure you write your code in a way that favors readability for people and not for compilers. Yeah.
Yeah, absolutely. And also, I just want to add also to the you aren't going to need it. Another way you can think of that is also like premature optimization. So, for example, in school, we're always taught to worry about runtime and space complexity and whatnot. But for example, if you spend like hours optimizing some algorithm to come down to a time complexity of like O log n instead of O of n, when you're, when n is never greater than like 4 or some tiny number, then it's probably a waste of time to, prematurely optimize that. And if you don't understand what I'm saying because you haven't taken these classes yet regarding time complexity and whatnot, my point is you don't have to try to make your algorithm be really efficient or your code really efficient if it doesn't make much of a difference in the actual world. So for example, again, you have a list of a maximum of 4 elements in your program. It probably doesn't matter if searching through that list is incredibly efficient or not, because even if you just go one by one, it's never going to make a difference. And that's not to say that you should never consider time complexity or anything like that. You should still talk about it, but you don't have to prematurely optimize your code.
So yeah, our first topic is gonna be beginner level. We try to aim it towards like freshmen and sophomore who are already learning the beginnings or basics of coding. This picture is just the left side, good code. People reading code or like what the fluff, like one or two, but bad code. You have your whole team asking what's going on here. So yeah, make sure you're on the left side.
Yeah, especially if you get a dude. Dudes are bad. So quick naming rules. You're often going to see people that name their variables in like for example just one character. So like they can name like a variable like an integer, just naming it x, which isn't descriptive at all. Especially nowadays where you have like autocomplete and IntelliSense and whatnot. There's absolutely no reason to not use descriptive names, and it's okay if they're a little bit longer. So it should be descriptive in a way that just by looking at the name of the variable, you should approximately know what it does. And I'm sure many of you will encounter code in your classes where you'll have a variable called like tz or something, and you'll be like, what's tz? I have no idea what that is. And that's exactly what we're trying to prevent. I'll make it easier to dive into code and understand what it does. Kobe, do you want to go over the meaningful distinction?
Yeah, we just alternate. So make meaningful distinctions. For example, if you have two variables, one for cars and one for trucks, don't put like int vehicle one, vehicle two. Make sure you separate like the two variables into actual meaningful names. To differ between them. So yeah, don't mix don't mix and match variables.
For sure. And then use pronounceable names. This will be more clear later on, but for example, if you have like a Boolean variable, and if you want to know if like something's ready, then you could call it something like is ready, which is something that's very easily pronounceable, as opposed to Exactly. We'll show you an example in future slides. But the point is, it should be something that you could easily read through. And if you get stuck on every variable name and you have to like go through it a few times in order to understand the meaning, then that's probably not good.
Yeah. So number 4 is use searchable names. Again, write like complete names for your variables or anything. That way you can control F and find it very easily. GitHub especially has like a search function that searches your entire code base. So having searchable names is very crucial to finding and fixing easily if you have a bug somewhere.
Sure. Next one is to replace magic numbers with named constants. So for example, if you have uh, a part of your code that is iterating from, I equals 0 to some number, more often than not, that number is supposed to be a constant, because if, for example, your for loop goes from like 0 to 4, it's not very clear what that 4 is or where it comes from. Or if you have some kind of calculation and you're using some number for that calculation, even if it's part of a formula, it's better to have a named constant. So just by looking at the code, it will be very clear and obvious what that formula is and what it does.
Yeah, so we're gonna have more examples on that later. Number 6 is avoid encodings. This one's hit or miss for me. I'm not really sure. But so encodings is for example, right? You have a vector or an array and you name it students array or student vector. So encoding means you're adding that word vector into the name, which it says here you're not supposed to do. But if you're like just starting out, you can you probably have a small enough code that makes it okay to remind yourself what that is. But later on, you're probably gonna know exactly what it is by what you're doing with it. So yeah.
Yep, for sure. Then using names according to the context, I guess that ties into being descriptive. But again, the variable, whatever variable you're saying in that context should be appropriate for that context. So it'll let you know more about that code in that specific section.
Mm-hmm. For number 8 is consistent names. So for example, you're coding your own project and you've been writing like code that with functions like receive students, receive teachers, receive this, receive that, and all of a sudden your friends start typing get this, get that, get this, and now you're like, wait, which one are we using? This is confusing because you don't at first you don't know if they're different or if they're the same like functionality. So make sure you use consistent like verbs in this case. So
For sure. And then finally, having meaningful names. And then this example of get user bank info or just get user info. Again, there isn't like a character limit or anything like that, right? This isn't a tweet, so we can just be as descriptive as we want when it comes to naming functions and variables, and that'll make it much easier to understand what they do.
mhm. Okay, so we're gonna go over a few examples here. The first one is magic numbers, which we discussed. So the one in red box is bad code. So for as Yuval said, for I equals 0, I is less than 50. If you were new to this code base, you'd be saying, what is 50? Why are we doing 50? The green box, however, declares a constant. So let number of students equals 50. That way, when we read the for loop, we know that I is less than number of students and not just a random magic number 50.
Right. And then very quickly, I should probably say for C++, for example, because I know many of you are going to be more familiar with C++, that could also be written as a constant number of students equals 50. So that's equivalent. That's the same thing, right? Then just naming rules. Oh, sorry, my mic cut off for a second. We mentioned Pascal and camel case before. So typically for most languages, at least you're going to be coding in, it's common to use Pascal case for classes. So for example, you can see here, they all start with a capital letter. That makes it easier to differentiate between uh, differentiate between classes versus just any random variables. But then the reason this is bad code isn't because of the isn't because it's Pascal case, but because the class is called make car as opposed to car, right? Because car is I'm assuming most of you have enough experience with objects by now, but car is going to be an object, right? So car could maybe have a function in it that's called make car, but this makes it seem like it's a function as opposed to a class, and that would just be confusing for whoever's reading it. And then another thing is using camel case for regular variables. So as you can see, camel case is very similar to Pascal, except the first letter is a lowercase letter. And then that also, again, makes it clear to see what is a regular variable as opposed to an object. Anything you want to add, Kobe?
No, sounds good. Very important. Here's favoring descriptive over concise. Just another example. So bad practice, you have a function called search user, and then we don't know what they're searching by. But good practice is search user by phone number. Notice how they didn't spell the whole phone number, just phone no, which is usually like no acknowledgeable by many people. So yeah.
Yep, and then it's way easier to see what this actually does just by looking at it without having to sift through code. At the end of the day, we want to save time because time equals money for code. So again, we mentioned before the single letter variable names. You don't want to just call something like X or P typically. The only time this is okay is if it's in a loop and it's used as an index. So for example, the reason we use I is typically because it stands for index or iterator or whatnot. So in that case, it's okay, but then don't name your variable something like Q or, I mean, definitely not functions. So yeah, you should definitely want to use a more descriptive variable name, but in a loop, it's fine because a lot of times you're going to see something like, if you have some kind of like array and then you want to access a certain element in the array, then you would just use this one letter. So in that case, it makes sense, but otherwise you definitely don't want to use a single letter for a variable name. Another good tip is using uppercase letters for all constant variables. Again, this depends on what environment you're coding in. Some kind of indication that it's a constant value would probably be good. I'm pretty sure Google has a coding standard where you would start with like K and then the name of the variable, right? So something like that. Obviously, your name should be more descriptive depending on context, but right now there is no context. So I just wrote constant value. But you might see something like this, like K indicating that this is a constant value. And also sometimes you might see people that proceed like a Boolean value with B. So something like that. You might see that depending on what the environment you're going on, but it's always good to make it clear that this variable is constant.
That's cool. I never knew about the Google thing.
Yeah, I looked it up.
Okay, so
this is all public, by the way. You guys, if you guys are curious, you can look up coding standards like Google coding standards and Unreal too, if you're curious. Go ahead, Kobe.
So here we have two examples. The left one is having a bad variable name. So D makes, I don't know what D stands for. Even though you comment it, we're going to discuss comments later on, but this is really bad. So for good, we have actual name. So like elapsed time in days, days since creation, days since modification, which are all good names because we know exactly what the variable is holding. In the middle, we have so this is what encoding meant. So having a count list, having that word list in your variable name is bad practice. So at the very bottom, we have good. So just accounts by itself without list. The right side is pronounceable names. So the top, we have Yumstra, which we can't pronounce, but at the good, very bottom, it's current date, which makes more sense. Again, you're favoring readability over machine, so make sure it's like proper English.
Yeah, 'cause Kobe could pronounce it because he's amazing, but most people can't pronounce it. So if Kobe can pronounce it, that's not good enough. Um, we also want to have consistent verbs per concept. So this is similar to the bullet point from earlier of like get versus fetch. Another thing you might see is, for example, make versus create. If these types of functions do a similar thing, then they should be named appropriately. So it'd be very obvious what this verb means in the context that you're working in.
Okay. Anyone have any questions on names? Feel free to ask in chat. But we're gonna go right into comments. So comments are pretty important. I myself use comments a lot, which I shouldn't do now that I've learned that. So one is always try to explain yourself in code, meaning your code should tell the reader what it's doing, not your comments. So if you read a for loop, then that for loop should tell the reader that's doing this, not like a comment before it telling you what it is. Number two is don't be redundant. Don't, so if you do comments, don't repeat yourself in comments throughout the code. Number three, don't add obvious noise. So don't like crowd your code with a bunch of comments that don't really add to the code. Yeah.
Yeah, and we can actually give a quick example of that too, because that might not be as obvious. Like for example, if you have something like this, right, where you just have int x and like int y. Again, don't actually name your variables like this. This is just for the sake of example, because I want you guys to watch me type for like a million years. But just for the sake of example, right? So you have this, and then you have right? So what we're saying is don't have something like right, like something like that. There's absolutely no reason for any of these comments, and that's what we're talking about. We're saying obvious noise. So this don't do. Also, horrible variable names. Two bad examples in one. Let's go.
We can alternate between. I forgot to alternate. My bad. So you can do for and probably show an example real quick.
Oh, sure. Yeah. So closing brace comments. I think we have some examples later on too. But basically, what we're saying is, if let's say you have something like, I think typically it's like if you have an if statement, if you have some kind of condition, and then you have like some comment here of like, this is typically going to be pretty bad. Another reason is I've seen sometimes people do this because the code is so long that you actually have to like scroll through. So by the time you get to the bottom, I guess you like forgot what the if statement is. If that happens, your code's probably too long to begin with anyway. So there's never really a point where you want to use closing brace comments. Oh, whoops.
For number 5, don't comment out code. So I know for what I used to do is I would write code and then I would like, I can make that better. So I would comment out like my old code and then write new code on top of it. Don't just delete it. No one ever needs to know what you did in the past. It's probably all documented anyways in Git. So yeah, makes it cleaner too.
Yep. Yeah, and we've all done it, so it's fine. It's fine if you do too. But sorry, we're on 6, right? So using the explanation of intent. So your comments should obviously explain the intent. So for example, if you are declaring some kind of variable, right? Even if it has a descriptive name, sometimes it's not completely obvious what it's going to be used for in the given context. So you can have a quick comment just explaining how it's going to be used or what might be able to affect it.
And then number 7 is kind of similar. So make sure your comments are actually like relatable to your code and not unrelatable. use it only as like clarification of the code, and which we listed we can do in many ways. So
Yep. And then as a warning of consequences could be something like, for example, if you have, most of you should be familiar with, actually, I don't have to complicate it. Let's say you just have some kind of variable that's like, let's say like num of students. If you're working in, sorry, I don't know why I did snake case. I'm pretty sure you use snake case in Python, by the way, so you might see that there. But let's say you have num of students as a variable, right? You can have the comment saying something like never be 0, because that might cause division by 0 or something like that. And obviously in your code, you should handle that regardless, but you can have something like that to indicate that if num of students is ever 0, then probably something went wrong if anyone looks at this code.
mm-hmm. Number 9 is important, so keep it short if you do write comments. If you have like a super long, like 3-line comment, people will just like look at it and be like, I'm not trying to read all of this, and they might ignore like a warning or something. So make sure you keep your comments short.
Yep. And then can we want to explain the last one, or if you want to
yeah, so every comment is a failure to express intent. So like what I said in number 1, your code should explain everything. If you do comment, then that means you failed to express what your code does at a specific part, which is true in many cases, but can also be false in some cases. So
yeah, your comments are supposed to serve as like an additional, something they should provide additional information, just because you couldn't be descriptive enough to begin with following all the guidelines we mentioned earlier with naming and your structure and whatnot. So they should serve some kind of purpose. It shouldn't repeat your descriptive naming or anything like that. Well, Kobe, do you want to take this one, or do you want to alternate again?
Yes, alternate. So number 1 is good code is the best documentation. Again, I repeat myself 3 times now. So your code should be the thing that's explaining itself, not your comments detailing what it does. Yeah.
Yep. And comments are difficult to maintain and almost always out of date. You should also keep that in mind when you write comments, right? So don't write something like, just to give a quick example, like, don't write something like, if this is 5, then we're full, or something like that, right? That's obviously something that could change. So don't write comments that are really reliant on like a particular state or period of time that you're writing it in. Write in a way that you're thinking like, okay, if someone looks at this in 10 years, this comment will still hold and still be descriptive and give some kind of information about whatever piece of code it is I'm commenting.
Yeah, people are lazy, so they'll most often not update any comments if they do write any.
Yeah, or miss them completely.
Yeah. Okay. I'll just take 3 and 4. So good comments are things with like legal matters, if there are any. Informative, which means like, oh, so this is how we declare variables. Like syntax and formatting. Clarifications, again, only do if you have to. So warning of consequences, to do is pretty nice, which might also be hit or miss because it might not be updated. And then public API documentation, if there are any that needs to be immediate in the code. As for bad comments, make sure they're clear and concise. Don't ramble on your code comments. Don't repeat yourself. So like what you've all said with the example, don't write this as a variable. Don't repeat yourself. Journaling, don't journal. And then also don't like section off parts of your code with comments. It should all be visible and readable without those. So
right. And by the way, for people who aren't familiar with like to do, you can see something like, for example, if you have a function which again, use more descriptive names. This is just for the sake of example. Let's say you have a function that you know you'll need to implement, but you haven't implemented yet. Sometimes you might see something like this, either something like that, like this, or sometimes it doesn't have the add. But this is something that you will often see, and I'm pretty sure some compilers or like IDEs sometimes even like let you cycle through different to-dos if they're marked in a certain way. But it depends again on like whatever environment you're coding in. For formatting, you don't want to have really long files. That goes back to what I said about if statements that where you have to scroll and you don't see the opening and close brace in the same window. Generally, you want to have separate files for every little thing or every little piece of basically every little piece of code should be responsible for one thing, and we'll touch on that later. And they should all be in their own file so that it's very easy to know what this file does and what it's for. And then it also makes it easier to find where certain problems are when you run into issues.
Yeah.
Do you want to take the second one?
Yeah. So good files, usually when you open them, have the heading at the top, like what they include, and then critical stuff, like important functions should be at the top, and then you write the details of those functions later on. So
yep. And then and also you can have a comment at the it's not uncommon to see a comment at the top of a file that quickly explains what it does. Or how it interacts with other classes. But yeah, don't use lines that are too long. What we mean by that is, so for example, here it's obviously very zoomed in, but if you had like, imagine that all these A's are actual code. So I shouldn't have to scroll horizontally to the right to see the end of this line. Something that you might see sometimes is if you have like an if statement with a lot of conditions, then sometimes what people do is something like that, where you just enter a new line and then you have the conditions listed like that, and then you can do it that way. So you might see that sometimes. Some people don't like that. Again, just try to be consistent. But I'm pretty sure also many IDs have kind of like a guiding line that will show you if you're over like a certain number of characters. That could also be useful to use. Anything else regarding that, Kobe?
Nah.
Let's go.
Yeah, so I want to take this one too.
Oh, me?
Yeah.
Oh, sure. So this is probably one of the most important things when it comes to consistency. I see people interchanging their like these different styles a lot. When you have any kind of braces, in this case we're using a function as an example, but this could be the same for classes or struct or whatever it may be. Please stick to one style. And if you're working in a file that you didn't create, that someone else did, follow whatever style they already went with, even if that's not what you're used to or not what you like. So for example, in 120B, I'm pretty sure that most of the files you'll work with are going to be in this format, or I believe that's in Zybooks, but I believe they use this kind of style. Whereas, for example, when I work in Unreal, you use this style. And again, when you work at a company, typically that'll be part of the coding standard as well. So you should follow that. And if you work in a file where like maybe it's one of your friends and they have an inconsistent style, then I guess at that point, do whatever you want and tell them to attend this workshop next year.
We are running out of time, so we're gonna probably speed run through these points.
Yeah.
Those intermediate. So yeah.
You could just go through it for now.
Yeah. So these are functions. Not sure you guys learned functions yet. I'm pretty sure it's week 6. I'm pretty sure you kind of touched on them. but keep functions small. Make sure they do one thing only. Make sure you use descriptive names, which we mentioned earlier. And number 4 is kind of subjective, but so you can pass arguments to functions, and we ideally want like the maximum of 3, which is again subjective. You can also replace those arguments with a struct that contains those variables, which is pretty advanced if you guys are freshmen, but yeah. Number 5 is have no side effects. So meaning like that function shouldn't change like much depending on what it does. Yeah. Number 6 is don't use flag arguments. So flag means like a boolean. If you pass in a boolean and that basically tells the function you can only do this or that, meaning 2 options. Ideally, you only want a function to do one thing. So yeah, don't pass in booleans in most cases. And then don't return null. So for 4, 6, and 7, these are all subjective. They can all be overridden. So yeah.
Cool. Just really quickly, we've mentioned this indirectly, I guess, but there's something called the single responsibility principle in CS in general. But especially in C++, you'll see even more specific documentation if you're interested. But the point is, every function and every class should serve one purpose, right? So for example, you can see on the right, you don't want to have one function that in this case does like addition and subtraction. You should probably separate those into 2, one that does addition and one that does subtraction, right? And this is obviously like a trivial example, but even with something that is more complicated, you can have functions within functions in a way that is separated, so it's very clear what everything does and what every piece of code does.
Here's an example of the flag argument. So in here in this function book, we pass in a boolean called is premium. At that point, we limit the function, or we allow the function now to do 2 things, depending on the state is premium. So we don't want that. Yeah.
And then just really quickly, again, this is depending on style. Even though typically you don't want to return null, sometimes you might have something that, let's say you have some kind of let's see, you have a class called person. If you guys have seen this before, if you haven't, don't worry about it too much, right? Well, let's say you have person and like it's like life, and that equals like, let's say this function can return null if like some condition isn't valid, then basically it would be up to the rest of the code to then null check and make sure that this isn't null. If you haven't gone to like pointers yet, or memory allocation or anything like that, don't worry about it too much. But the point is, your code should be doing null checks regardless. So sometimes there might be a case where it's okay to have a function return null.
So this is understandability. So be consistent, meaning if you do something a certain way, or if your environment does something a certain way, keep doing it. Number 2 is use good variable names. So as mentioned before. Number 3, avoid logical dependency. So don't write functions which work correctly depending on something else. I think it should be obvious, but some people do it sometimes as a mistake, and it creates a lot of like weird things. Number 4, avoid negative conditionals. So A, if car dot should move, that's the correct way to do it. Don't do B, if not car dot should not move, which is kind of a mouthful, but yeah, it happens.
Yeah, for sure. And it also is way more confusing to read. So just very quickly, for the structure of your source code in general, you want to separate concepts vertically. So I mean, it should be pretty intuitive, right? Like typically we'll have functions or classes grouped together in a way that if they interact with each other, then they'll be close to each other. And that makes sense because also you don't want to have to keep jumping back and forth in order to see what's going on. a related code should appear vertically dense means that you can use spaces to separate different variables that maybe don't interact with each other directly, as opposed to ones that do, that would be only like one line apart. Declaring variables close to their usage is again related, that you want to have variables declared very closely to where they're going to be used. And in fact, for example, if you have some kind of if statement with some condition, if you have a variable that you only need inside the if statement, then you should declare it here, right? Because if you were to declare it here, but it's only used in the if statement, then first of all, that's wasted memory, but also it makes it seem as if this variable would be needed otherwise. And that just makes the code hard to understand. Similar functions should be close. That's again related to everything being vertically dense based on usage. Place functions in the downward direction. Kobe, do you want to explain that one?
I guess just write your code downwards. I guess people do some other things which, like, yeah. So
Oh, right, that's the whole like
yeah, don't
like
don't
yeah,
yeah.
stuff like that. Yeah, absolutely. Yeah. The only exception, actually, the one thing you guys might see sometimes, if it's like, you know, if you have something like get user, do something like that, if that's really all it is, right? So that's fine, but otherwise it should never be like that. And that's also like in a header file when you typically have classes and whatnot. But again, keep lines short. I mentioned that before. We want it to be easy for anyone to look at your code, no matter if they have ultra wide screen monitor or not. Don't break indentation. That's a common issue that we see with people that start. So for example, if you have something like while some kind of condition 1, right, and then you'll have an if and some kind of condition 2 inside here, right, you should be properly indented and consistent, where like, let's say in here you write some stuff, right? This is very clear to know like what's going on in what scope, right? But if this moved and this was here, this is very confusing to read, right? Or like if you did this, right, that's already like infinitely harder to understand what's going on. So don't do this, do that. White space carries information. Again, we mentioned that before, how you can use space in order to make things more clear. So a lot of times you might have, you know, all kinds of like things like that, and then you can have all kinds of stuff going on. Sometimes just adding a new line here and there makes things infinitely easier to understand. And again, don't pay attention to the variable naming. It's just for the sake of example, because we don't really have context right now. And again, one line between methods, which is another word for functions. If you guys are only learning C++ and you haven't seen them referred to as methods before, but variables, loops, etc. Most of the time, it just comes down to being consistent, because the code you'll work in, especially if you guys are in Zybooks, then you'll see there's some kind of convention already in place, and your code should be consistent with it.
This is advanced. These are advanced tips. We'll probably just like fly through these, and then the ending. So it's like 4 slides. So yeah.
Cool. Yeah, Kobe, you want to just fly through it then?
Yeah. So design rules. So keep configurable data at high levels, and then prevent over configurability. So meaning keep things you can change at a very high top. Like you don't have to dig into your code to change things. And also like don't change too many things. Don't have too many changeable things. So number 3 is use dependency injection, meaning so for example, you have a class named car. You should probably have another class named engine. That way they depend on each other, and not have engine as part of car. And then yeah. Number 4 is law of the meter, meaning So the law of the meter states like talk to immediate friends only and don't talk to strangers. So your classes should only like talk to people or objects that they know and not like far away things. In terms of code. Yeah. Um, you want to do this real quick? Slide through.
Sure. So just really, and again, if you haven't learned this yet, don't worry about it. It's all good. You will learn it eventually if you haven't covered it yet in your classes. But this kind of related to an example I gave before with using a struct to pass in many variables. You should have objects for certain parts of your code that where it makes logical sense for certain variables to be grouped together. You should prefer data structures. So that sounds fancy, but an example could just be using an array, for example, where it makes sense as opposed to having separate variables. Should be small and do one thing. That's very related to like the single responsibility principle that we mentioned before. Your objects and data structures should serve one purpose and be consistent with whatever context they're introduced in. Small number of instance variables, that really comes down to the whole object being small. So for example, if you have a class that has a lot of variables and functions and just functionality in general, there's a good chance that it should have been broken into smaller pieces, which is very similar to what Kobe said about like having a car and an engine, which would be a separate class rather than having all the engine logic inside the car class. And then 5 again is reiterating that similar thing that base class should not know nothing about their derivatives. Sorry, about derivatives, that means that like if you, for example, you have class animal and you have like dog and cat that derive from it, then animal shouldn't know anything about dog or cat, right? And again, if you haven't learned that yet, don't worry about it. But it's better to have many functions and to pass some code into a function and select a behavior. That means that again, you can break your large functions into smaller functions based on functionality, and then it's way clearer to understand what's going on. And Kobe, do you want to take the last two?
Yeah. So for classes, you probably want to keep it private. So this is more like later on, probably in different environments. You prefer to keep your private stuff at the bottom and your public stuff at the top. But in school, you generally want to keep. I mean, I think they suggest to keep like your private, public, protected stuff at the top anyway. So, number 8, step down rule. You can probably Google this, but it means to like write your classes in abstract at the top. So like declare stuff and then go more detail at the very bottom as you traverse down. So, yeah.
Yep. And that helps with understanding what each class does as well.
And then last topic for advanced. So tests are something you're gonna do. They're very important. So it might not make sense now, but for tests, you only want one insert per test. Make sure the test is readable, like we know what it does. Make sure it's fast. You don't want to fail a test and have to wait 10 minutes for the test to finish again. Make sure that each test is independent of each other. So don't have a test rely on another test to pass. And then make sure they're repeatable, meaning you get the same results each time. So yeah, some big code no-nos. So for number 1 is rigidity, meaning don't have your code be difficult to change. Like so in that case, don't like if you change one part of your code, don't have that part all of a sudden cause a bunch of changes throughout the entire code. So make sure you keep your code like fluid. Number 2 is fragility. So again, relates to number 1. Don't have your code break just because you make one small change. So yeah, keep it separate. 3 is immobility. Meaning you can't reuse code that because it'll take high effort to reuse it, and also because of high risk if you reuse it. So make sure you keep it small and single function. 4 and 5, pretty simple. Don't have like long code doing the same thing and don't overcomplicate it. And number 6 is just, you know, keeping your code easy to read.
Yep. So some last words before we finish is just this has more to do with what kind of attitude you should have when you're writing code in general. This is obviously like there's no such thing as being perfect or having perfect code, but if we all try our best, then you know the world will be a better place. Like that picture of how the world would be if everyone attended this workshop. Code, you want to take the next one?
Yeah, so people, when you start working with people and you have good clean code, people will be like, wow, this is amazing, I've never seen this before. So yeah, people will start loving your code. Yeah,
For sure. And again, we're saying to take all these rules with a grain of salt because these are just guidelines, and the most important thing, the only real rule, is to be consistent with whatever environment you're working in. And for those of you who aren't as experienced yet with just looking at code or just programming in general, you'll start to see you'll start to code in more and more environments, and then you'll kind of start to get a sense of what you like and what you don't like and what you think makes sense or not. But at the end of the day, being consistent is the most important thing.
and have fun. Woo.
Yeah, so I think that's it for our workshop. If anyone has any questions, please let us know.
Yeah, I think we have a few more slides.
Yeah, I know, but
yeah.
this is
Resources.
basically the end of the actual workshop. So if anyone has questions, feel free. These are some resources in case you want to look at more things that relate to clean code. And
yeah, I do want to give credit to Vince, our ACM member, or a board member. So he came up with this idea. So yeah,
Vince is awesome.
And make sure you guys sign up to Cutie Hack, where you can apply this clean code. So,
yeah, you can apply the clean code and make other people read it and criticize their code for not being clean. Yeah, thanks for coming, everyone. If anyone has any questions, not just right now, but just in general, always feel free to message us on Discord or email us, and we will gladly respond and help out.